continue. So in the so there are 10 questions in this exam, and in the last question, if you see there is mistake. So we will just try. I will give you the hints for every question so that you can solve them. So from where you want me to start? From the end or from the start?
The end.
First two, because they are review from midterm, so question 3. Okay, so let's do the question number 3. So question number 3, okay. Why it is not doing this one? Okay, final exam. Question number 3. In the question number 3, we are given find the work done by the force along the closed curve formed by this and this and this. Assume counterclockwise orientation. We will talk about later. So this is the F. F is equals to what's wrong with you? F is equals to minus x square y unit vector I plus y square x unit vector j. So this is the F, and the boundaries which are given is y is equals to 0, x square plus y square is equals to 16, y is equals to x, and x square plus y square is equals to 4. So work done by the force along the closed curve formed by this one, and we are going to assume the counterclockwise direction orientation. So this is our x and this is our y. Now x is equals to y means it is 45-degree angle and it's a line. So this is x, y is equals to y, x, y is equals to x. Fine. Now, this gives us a circle which has the radius 4. So let's say this is 4 and this is circle is going like this. So it is 4 here. And then this is the circle with radius 2. So this is 2 and this is going here 2. Fine. Now, y is equals to x on this line, y is equals to 0 is on this line. If I draw, this is y is equals to 0, and this blue line is y is equals to x. This green is a, where should be green? So green is a curve where x squared plus y squared is equals to 16, and yellow is a curve where x squared plus y squared is equals to 4. So this is our counterclockwise orientation. So by this we will write, okay, this is our C1, this is C2, C3, and C4. Fine, you got this picture? You got this diagram?
Yeah.
Yes.
Okay, so now let's start to solve this one. Work done is F dot dr. So in this case, we are given F. So F is equals to minus x square y I unit vector plus y square x j unit vector. dr is dx I unit vector plus dy j unit vector. So now there is a dot product with them, so it is becoming minus x squared y dx plus y squared x dy. So this is, we have simplified it, one thing. Now we will solve it for the curves, okay? For C1, C1 was in the red color. So for C1, we have our X goes from 0 to 4, fine. And Y is equals to 0, fine. It means dy is equals to 0. So if I write it correctly, on our C1,
Excuse me, I have a question.
yes.
Why are we assuming it's the top right half of the circle? Because there's also a region in the bottom left half.
Yes, you are right. There is.
So why are we only doing the top one?
We are told that go from a counterclockwise direction, fine.
I guess, but there's two regions, so I just don't understand why we do the top one and not the bottom one.
So when you will use the bottom one, then what will happen? Things will be in the negative, fine. Because, okay, we will discuss it later. First, let's the finish, fine. This is a very good question, but in the curve C1, when it is X is equals to 0, and so X is going from 2 to 4, so X is positive. When Y is equals to X, so it is positive, so that's why we're in the positive region. Now let's solve it. So for the first part, for the first C1, our Y is 0. So first term becomes 0. So dy is also 0. So second term becomes 0. So it is 0. Fine. You can write it is from going from 2 to 4. So this is already 0. For the curve 2, okay, we have the color for curve 2 as green. So let's go for that. Green. So in the green, if we look, our X goes 4 and Y is equals to X. Fine. So if I write this is the X square plus Y square is equals to 16 circle. So we have X is equals to Y is equals to X. We have X square plus X square is equals to 16. This means 2X square is equals to 16. So do you know why I'm doing this?
You
You said something else and wrote
equation.
something else. So I will answer, Yanush. Yes, what was the question?
No, I wasn't answering the I wasn't asking a question. I was answering your question. You said why is it like this? You just subbed in the x, y equals x into the first equation.
Yes. So that here, if we look here, this is our curve, this one. So here we have y is equals to x, and here our x is 4, fine, and y is 0. So we are finding the point over there. So here x will be equals to x square will be equals to 8. So x is equals to 2 under root 2. And y is equals to x, so y is also 2 under root 2. One thing is clear. Now for the C2, we are starting from x is equals to 4 and going till 2 under root 2. This is our limits for x. And our term, we will convert it into x. So from here, y0, y square, let me erase this one so we can write it here. So, sorry. y square is equals to 16 minus x square. So y is equals to 16 minus x square square root. So we will replace our y with x, and we have to solve only in one term, one variable. So we have x square, first is minus x square y. So minus x square y is 16 minus x square under root, and dx is there, fine. And in the second part, we have dy. So dy will be equals to 1 over 2, 16 minus x square minus 1 over 2 multiplied by minus 2x, so dx. So you can solve that by yourself. It's not big deal. Plus y square is 16 minus x square multiplied by x multiplied by dy. So dy is minus x over 16 minus x square under root dx. So this is, you can see. Can you see what I have written here? So this is our term starting from here till here. Now we can solve it in the x. When we are solving the no, just do it normal way. I think normal way is fine. So by solving it, we get minus x square, 16 minus x square. This will also become 16 minus x square square root minus x square. So we have 2 times same term. So 2 under root 2 dx. So
Excuse me.
this will become,
Can you please write it less crowded?
oh, okay. Should
you.
I make it? Okay, I will try.
Thanks.
Sorry for messiness, sorry. So let me make it a little bit bigger. So we will have 422 under root 2. We have to add these two terms. This is same term, so it will be 2 minus x square, 16 minus x square dx. Now it's easy to solve. This will be equals to 16 pi. When I solve, you can try it at your time because just the integration. For the third curve, okay, third curve, if we look at it, this is just the line, this line, which is blue color. So this line is going from 2x is to,
Can I ask a quick question?
yes.
Would this question not be really simple to switch to polar coordinates to solve?
Yeah, yeah. I think so, it will be. But I did it in simple way,
Okay, thank you.
okay? Could we also use Green theorem? So if it is not written that you should not use it, you can use it, right? So this is the simple line curve. So we will use it. So C3, for C3 we have 2 under root 2, because direction is going from 2 under root 2 to 2 under root. This point, which is at the line, is 2 under root. So this will become minus x cube. Now x is equals to y, dx is equals to dy. So we will use this minus x cube dx plus x cube dx. It is going to be 0. So it is again 0. Okay, how it is 2 under root? So let's go and check. So this is the point which we have here. So if you draw here, this is, you can see that it is not equals to 2. So it is different point. So you can solve it. You can, how it will be 2 under root. So here x square plus y square is equals to 4. and x squared plus x squared is equals to 4. So 2x squared is equals to 4, x squared is equals to 2 under root, x is equals to 2 under root. So it is 2 under root, fine. So every point you have to consider, okay? This is the point, this is x, this is y, and then you go ahead. Now for the last curve, which is the small circle, we have, this is our C4, this is the direction. It is 2 under root here and 2 here. So let's use yellow color. For the I4, we take x as a parameter. X is parameter. Keep it in mind, I took x as parameter so that everything should be in the x format. So this will be equals to 2 under root to 2. We have minus x squared. Just like as we did for the big circle, we have this time small circle with radius 2. So 4 minus x squared dx plus 4 minus x squared x dot minus x over 4 minus x squared dx. So by calculating, by adding it similarly, we again get double. So it will become minus 2 under root to 2 minus x squared, 4 minus x squared dx. So when you will solve it, it will become minus pi. So when we will calculate them, so I1 plus I2 plus I3 plus I4, it will become 16 pi minus 0 plus 0 minus pi plus 0. So I made some, so first one 0, so it is equals to 15 pi. So where did you get x cubed from? So x cubed come because in the here in C3, we have x is equals to y. So I replace x with, I replace y with x, and dx will be dy and dy with dx. Okay, I will send you the recording as well as the my notes. So don't worry, if we couldn't solve it, I will send you, which I have tried, but there are other ways. If you have quicker method, that is better, okay? So now which question? Let's move to the,
Wait, before we move to the next question, can we just use Green's theorem for this question?
can we what?
Use Green's theorem.
Green theorem. So we have only 2 hours in which 10 questions. It's a very, very big target.
No, I just mean like instead of doing all of this, can we use Green's theorem on the exam?
Yes, you can. If it is not written that you don't, for example, in the paper, if you look, which is given to you, they have given the same question 2 times and they said, don't use Stokes theorem here and use Stokes theorem here. So if there is no condition, you should use Green theorem. Any other question? What was the final answer? 15 pi. I got 15 pi, but you check also. Okay, so maybe I have made mistakes in my notes. So try to keep an eye. But the method is this one. So question number 4, should we use it? Should we do it? It's right. Thank you, Aditya. So should we do question number 4?
Yes.
Okay, so let's do question number 4. Question number 4. Line integral, evaluate f dot dr assuming c is oriented counterclockwise. There will be no credit if the Stokes theorem is used. I was just telling you this one. So our f is x plus 2z with I unit vector plus 3x plus y with j unit vector plus 2y minus z with k unit vector. C is the curve of intersection of the plane x plus y plus c equals to 1 with the coordinate planes. There will be, okay, so this is, so let me write first C so that, okay, C is equals to x plus y plus z minus 1. Okay, this is our curve, fxyz. So if I look at it, so this is xyz. If I put x, y and z 0, so my x is 1, this is 0.100. If I put x and z zeros, this is 0, 1, 0 point on y, and this is 0, 0, 1. Fine, these are our points. So this is the surface. Now let's find our integral. So integral is closed loop f dot dr. So this is x plus 2z I unit vector plus 3x plus y j unit vector plus 2y minus z k unit vector. So this is our f. Taking its dot product with dr, we have dx I unit vector plus dy j unit vector plus dz k unit vector. So this will be, this is dot product, so we will have x plus 2z dx plus 3x plus y dy plus 2y minus z dz. So this is the integral we have to use. Now, let's say this is our I1, I2, and I3, three integrals, fine. So I1 is the closed on all poles, all curves, x plus 2z dx, fine. Look at our regions again. I will draw them here. So this is dx in the xy plane, C1, okay? So C1 is x and y plane. So this is our xy plane. X and y. This is the curve we are talking about, counterclockwise. So here, our values are 1, 0, 0, and here our values are 0, 1, 0. Fine. Z is 0, x goes from 1 to 0, and y goes from 0 to 1. Fine. So we will do it in this way. So in the C2, again, we have, this is our y and z, and this is the line. Direction is this one. So our x is equals to 0, and this point is 0, 1, 0, and this is 0, 0, 1. So y goes from 1 to 0, and z goes from 0 to 1. In the third, we have, that is x and z. So this is our z, and this is our x. So this is our C3. Direction is this one. So here we have 1, 0, 0, and here we have 0, 0, 1 is here, and we have 1, 0, 0 here. Fine, these are points. Let me correct it. I don't think you can see correctly. So this is Z, 0, 0, 1. In this curve, our y is equals to 0. Our x goes from 0 to 1, and z goes from 1 to 0. So these are, we will repeat. Okay, So now C1, C2, C3, we have defined, we know where X is 0, where Y is 0, and where Z is 0. So we will apply these in all integrals. So integral 1 is going to be C1 X plus 2Z dx plus C2 X plus 2Z dx plus C3 X plus 2Z dx. So, okay, after this, we will go to the problem time. So in the C1, we find that, okay, it is going from 1 to 0. And this is X, Y is 0, Z is 0. So X dx plus in C2, we have 0 to 0 because Y is going from 0 to 0, X plus 2Z. And it is 0, so limits are 0, everything is 0 here. So for the third one, we have 0 to 1, X plus. Now we have Z, 2Z.
On top of the fucking
Sorry.
projects and all the
Group
dynamics.
projects, man.
Like even if you have a good team, shit falls apart.
I hate it. The problem with group projects is like it's supposed to.
Okay, thank you very much. So now we will solve it. It is easy in the dx form. So we have x squared by 2 from 1 to 0 plus x minus 2x. So it is 2x minus x squared by 2, 0 to 1. So we solve it and we get minus 1
So-
over 2 plus,
Lucia,
yes.
I just have a question. So the second term that you put it on, is that integral like 0 to 0?
Because it is C2 is in the YZ plane.
Oh, okay, so it's 0 to
So
0.
it
Okay,
is,
great.
our X goes from 0 to 0.
Okay, right. Thank you.
So now we will solve it and we get 1 here. So this is our first integral. For the second integral, we have 3x plus y dy, and it is on all the curves. Fine. So now I have given you in which curve you have 0. So here, our y values, okay, goes from 0 to 1, 3x plus y dy. Fine. So we can convert our x into y format. So it is going to be 1 minus y. So it is 1 minus y multiplied by 3 plus y dy. Then we have second term from 1 to 0. And here x is 0, so y dy. And third term, dz, it is going from 0 to 0. Yes, y is 0 in the third quadrant, so it is 0. So this term became 0, and we have 3 minus 3y plus y, 2y, dy, 0 to 1 plus y squared by 2, 1 to 0. So this will become 3y minus 2y squared by 2, 0 to 1, plus 0 minus 1 over 2. And solving it, we get 3 minus 1 and minus 1 over 2. So it is 3/2. Okay. So this is our I2. I3 is going to be 1 minus x for the third integral. Can you go over how you got 1 minus x? Where? In the previous integral? Okay, so I will write here. So our curve is, let me write curve. So let's write green color. Green color. So here, our curve is x plus y plus z is equals to 1. Fine. So here z is 0. So it means x plus y is equals to 1, where you are asking me. Fine. So y is equals to 1 minus x. Similarly, it is for every there. This is for C1. Okay. And you will get other terms as it is in C2 and C3. So now we will go for I3. I3 was 2y minus z dz, and let's make it C1 plus C2, 2y minus z dz plus C3, 2y minus z dz. Fine. So I will apply the limits which we have for the first term, for the first curve, our z is 0. So it is going from 0 to 0. So this term is 0 plus. For the second term, z goes from 0 to 1. And y we will take 1 minus z dz plus 2 into 1 minus z. But in this, in the third quadrant where the third curve is, it is 0. Y is 0. So it will become 1 to 0 and y is 0. So it is minus z dz. So now it is easy. We have 2 minus 2z minus 3z. So 3z squared by 2, 0 to 1. After integrating it, sorry. Minus z squared by 2, 1 to 0. So this will give you 1. After adding all them, I1 plus I2 plus I3, we will have 7/2. This is solution. Okay. So after this, in the fifth question, you have to use the Stokes theorem for the same problem. So should we do it first or 10th first? Could we do question number 9 next? Okay. So zoom out.
And then 10,
Zoom
please.
out. Can we zoom out? I don't know how to zoom out. So I will send you the notes, okay? It's not like I will send the notes today, inshallah. So question number 9. You want to do question number 9. So let's do question number 9 first. I want you to do from the back side, but fine. So question number 9. In the question number 9, we have find the volume of the solid that is bounded by the graphs of the given equations. So we have z is equals to x squared plus y squared. 2z is equals to x squared plus y squared plus 4. And we have x is equals to 0 and y is equals to 0. So these are the boundaries we have, and there's a solid which is bounded by these graphs of the given equation. Fine. So if we draw it, this is, I'm going to draw it, sorry. This is z, this is y, this is x. Okay. Now z is equals to x squared plus y squared. So there is a circle which is increasing in the size as z is increasing. So it is like, you know, a bowl in 3D. And now the second one is this one. You can write it as z is equals to x squared by 2 plus y squared by 2 plus 2. So you see there is a shift. Here is a 2, z is 2, and x squared plus y squared divided by 2. So first let's complete this one. Let's have cut here that we have cut this circle here. So try to be imaginative as much as possible. And now we have other boundary which is going from this side. And it is shallow, you know. So this is the curve we have. Now, where is the, so this is our z going up. This is our y. Please mute if you don't, please mute if you don't want to ask the question. So this is our x, this is our y, fine? Now look, this is the boundary with this point and this is the boundary with this point. So this is the cut. Because x is equals to 0 and y is equals to 0. So here, to my understanding, this is the area we are going to, this is the solid which is bounded here, and we are going to find it. I hope so. So if there is some mistake and you want to express, you can express it. But I think this is the way it is going to happen. So you understand that diagram? Because it is very important in this vector analysis if you can imagine what is happening.
I just have a quick question.
Yes.
So if in the original one it was x squared and y squared, for the second one, if it's x squared over 2 and y squared over 2, shouldn't it be like shorter?
So it is shorter.
Can you show how it's short? I think it's a little bit difficult because it's 3D to understand.
Yeah, this is the one. Okay. So it is when x and y 0, it is at 2, fine. And it is shallow because our circle is x is divided by 2 and y is divided by 2.
Okay.
Okay. So how, what is the question? How you analyze the equation in 3D? I have a hard time figuring out what the shapes looks like. Okay, again, let me write it here. So x is equals to 0, y is equals to 0. This is the point, fine. When you have a circle, you have a little circle here, then your z value increase, you have a little circle here, then you have a circle, and this is going your x squared plus y circles, fine, in 3D. So if you analyze, this is like a bowl which is increasing its radius per time. And then another is there where it is x squared by 2 plus y squared by 2. Okay, it is the half of the radius. So it should be shorter. I think then we are adding in it 2. So the value is going to be, in my opinion, it is going to be like that. So hopefully you can understand it now a little bit. So any other comment? I might be wrong. I'm not saying that I'm very perfect, but I tried. It is my opinion that it is this shape. So
Oh, wait, again, quickly, before you erase that.
yeah, sorry.
So if the thing was like, let's just say like 5, we'll call them circles tall, x over 2 should have been like 2.5 circles tall, for example, right? So it'd be like about half the figure that you drew. So how come it's dipping from the top? That's what I'm having trouble understanding.
Oh, you are not understanding this one. Fine. Look, if I have
Because it says +2. It's x
x is equal
squared
to
plus
0,
y
y is
squared.
equal to 0. So z is equal to 2. So its bottom is at 2. Fine.
Yeah, okay.
Okay. And then you are adding it like 1/2 plus 1/2 plus 2. So it is 3. So it is going to be, you are saying that it should be smaller like this?
He's asking why it's starting at number 2 on the Z.
So
Why it's up 2.
no, that
I
is
believe-
why,
I believe.
because when your x and y is 0 for that circle, your z is 2. So it is going to be at z is 2. It is a shift. Whenever there is a constant, it's a shift. Right? So it's a shift here. The bottom is shifted here. So let's solve the problem. Fine. Hopefully it is correct. So our z goes from x square plus y square. This is the lower, and it goes till x square by 2 plus y square by 2 plus 2. This is our z boundary. And we know that y is equals to 0 and x is equals to 0. Fine. Now at this bottom point where z is 0, your y is equals to 4 minus x square under root. Fine. X square plus y square is equals to 4. So you got this point or not? Okay, let me explain more. So we have z is equals to x squared by 2 plus y squared by 2 plus 2. So z is 0. So it means x squared plus y squared plus 4. So this means okay. So I made a mistake, some mistake here. It is 0. No. I didn't make a mistake, so I'm explaining wrong. So we have z is equals to x squared plus y squared, and other z is equals to x squared by 2 plus y squared by 2 plus 2. Fine. So now we will solve it. It is equals to 2 is equals to x squared by 2 plus y squared by 2. So this is x squared plus y squared is equals to 4. And y squared will be equals to 4 minus x squared. And so this is our y. Y. Now if our y is also 0, so it means x squared is equals to 4. X is independent of everyone, so x is equals to 2. So this is the boundary, maximum boundary of x and y. So let's write them here again. 0 to 2, 0 to 4 minus x square under root, and we are going from x square plus y square to x squared by 2 plus y squared by 2 plus 2. dz, dy, dx. Okay, so this is we have to solve. Now it's very easy to solve. Do you want me to integrate it? Yes? Oh, okay. So z is equals to z, dz is z, so it is going from x square plus y square to x square plus y square plus 4 divided by 2, and here it is 0, 4 minus x square under root and 0 to 2. Here is dy dx. So let's put the values. We have x squared by 2 plus y squared by 2 plus 2 minus x squared minus y squared. And this is our dy dx. So if I solve it, we have 0 to 2, 0 to 4 minus x squared under root. We have 2 minus x squared by 2 minus y squared by 2. dy dx. So integrated 2y minus x squared by 2y minus y cubed by 6. And it is going from 0 to 4 minus x squared dx. Here our integral is 0 to 2. So this will be equals to 2 into 4 minus x squared minus x squared by 2, 4 minus x squared minus y cubed, so 1 over 6, 4 minus x squared, 3 by 2, dx, 0 to 2. So what I will get the answer, it's going long, but I can tell you the answer is pi. X squared plus y is equals to 4. So I draw it here, okay? So we have z in both forms, so equate them, and you will get your values in y and x form. Yeah, it is y square, yes. Did I write y? Do you want me to continue integration? It's fine. You can check your answers pi. I got pi.
Can we do question 10?
Okay, we can do question number 10.
Sorry, just quick. Why didn't you
Yes.
put it in polar coordinates?
Sorry?
Why didn't you put it into polar? You left it in rectangular.
You want me to do it on polar?
No, I'm just asking why you did it in rectangular, not polar.
Because it's not written and what I feel easy, I do that.
Okay, all right, thank you.
Okay. I mean, this is the trick. If you are not asked by something and which you feel easy, which you feel comfortable, do that. So question number 10. In the question number 10, if you look, helix RT is equals to 2 cos TI sine 2 sine TJ plus TK, and there is 20013 pi. So there is a mistake in this question, in my opinion, but you can check with the professor. So I will try what I think the correct question is, but you can ask the professor, okay? So question number 10. Our f is 8x y square I plus 12x square y square j plus 4x square y cube k. Acting along a helix, and helix is RT, which is, I will write it as 2 cos of t I unit vector plus 2 sine of t j unit vector plus tk. And the point which is going from, it is going from 2, 0, 0, but the other point 1, 3 pi with this is not possible. So I made it 2, 2 pi. So it should be 2, 2 pi in my question, in my opinion. Yes, this question has typos, in fact. So I will solve with these points, okay? The method will be, you know the method and you can do it. So our RT is given as, so dr will be equals to minus 2 sine of t, dr by dt will be
Excuse
equals
me.
to, yes.
Is that 2 pi on the
Yeah,
right side?
yes, I write it 2 pi.
Thank you.
Right. Because when I put things, these values, they worked, but when I put pi, they don't work, 1 and 3. So I think it should be 2, 2, but you can confirm it with professor. So minus 2 sine of t plus 2 cos of t, where it is gone. Plus, this is I, close. Plus 2 cos of tj, okay, plus k, unit vector. So it is 1. Now we have, in fact, RT is usually x, which is function of t with I unit vector, plus y, j unit vector, plus z, which is function of t, k unit vector. So if we compare our f with it, so our f becomes x is equals to, sorry, comparing r's values, we have x is equals to 2 cos of t, y is equals to 2 sine of t, and our z is equals to t. So let's put these values into f, and f dot dr, we have to find, this is our work. So f will become 8xy squared, so it is 8, 2 cos of t, y squared is 4 sine square t, and now it is I, so I will, with this one I, we have dt, so it is just finish, plus, you got the point? Yes, if we have time and if I have charging on my tab. Otherwise, I will send you the solution of question number 8. I will try to send all of the questions, okay? So 12, we have 4 cos square t, 4 sine square t, plus 4 into 4 cos square t, this is my f only. Okay, 4 cos square t and 8 sine cube t. So this is I, this is j, and this is k. So let's go for the f dot dr. So if, let more simplified, 64 sine square t cos t, I unit vector, plus 192 sine square t cos square t, j unit vector, plus 128 sine cube t cos square t, k unit vector. This is our f. Now f dot dr, after multiplying, if I write it is 1 minus 128 sine cube t cos t plus 384 sine square t cos square t plus 128 sine cube t cos square t dt, and it is going from 0 to pi. T is given from 0 to pi. So now from here you can solve. Okay. So question number 8. For the second term, wouldn't it be cos cube t? Wouldn't it be cos cube t? Yes, it is cos cube t. You are right.
Can you quickly solve that? Because it's an 8-point question. Seems really illogical to have a question like that to solve.
Question number 8. Yeah.
No, I meant question 10, the one you were just doing. Can you finish that one, or would
Yeah,
you?
inshallah. It has 10% charging, so hopefully let's do it. So in the question number 8, we have, my tab is giving me very hard time. So yesterday, that's why I canceled. It was not charged. Today, I hardly charged it. It was so giving me. Okay, but let's do it. 3x squared minus 3xy equals 0. So this is our 9. This is our 8th question. At which the tangent plane, find the points on the surface at which the tangent plane is parallel to the xz plane. Bound for question number 10, it is given 0. T is given in the, because z is equals to t. So z goes from 0 to pi. So t goes from 0 to pi. So this is our question. So, there is a surface like this one going, and we have, this is xz plane. Okay. So there is a tangent plane is parallel to the xz plane. So there is a tangent plane which is touching this surface. And now this surface, I don't know, it can be any type of surface, but it is touching. And now there is a rule that, I have written that, that normal to tangent plane is equal to normal to surface at point where they touch. So it means we have to normal to tangent plane. So we have to find the line which is parallel to normal, fine? So for that, I will use, so our fxyz. Did you get the point? Hopefully. Okay. fxy is equals to x squared plus 6y squared plus 3z squared minus 3xy minus 9. It equals to 0. This is our function. So for the divergence of f, we got del f. So it is going to be, my notes are, but so we are finding the vector. This will give us a vector along normal to surface S. Okay. So this will be equals to partial x over f plus partial f over partial y plus partial f over partial z. So this will be equals to 2x minus 3y I vector plus, and there is I here, j and k. Curl f over curl y is going to be 12y minus 3x j vector. Curl f over curl z is going to be 6z k unit vector. So this is our del f, gradient f, whatever you call it. So now tangent plane is parallel to xz plane. Okay. Tangent plane is parallel to xz plane. So when it is xz plane, its normal will be along y-axis. Fine. So our term will be 0, 1, 0. This is the vector we will have because its normal will be along y-axis. This is our xz plane. So now we will find our values. So it means 2x minus 3y equals 0 equals 6z. So z is equals to 0 and y is equals to 2 by 3x from this figure equation.
Sorry, do you mind just going up
Yeah.
quickly?
Yeah.
I'm just trying to figure out the gradient x, why you pulled the negative 3y and put it into the I and the negative 3x and put it into the j.
So here we have minus 3xy. When I will differentiate
Yeah.
it with respect to x, it will become minus 3y. And when I
Okay.
will differentiate it with respect to y, it will become minus 3x.
Oh, okay, you're differentiating the whole equation. Okay, yeah, no, I understand. Thank you.
Okay. So now we have z is equals to 0, y is equals to 2 by 3x. So let's put these values in our equation. So we have x squared plus 6 multiplied by 2 by 3x squared plus 0. 3z squared is 0. Minus 3 x and y is 2 by 3x minus 9 equals 0. So this is our x for xy. So it will become x squared plus 8 over 3x squared minus 2x squared equals 9. So we have 8 by 3 minus 1 x squared is equals to 9. This will be equal to 5 over 3 x squared equals 9. So x squared is equals to 27 over 5. Your x is plus minus 3 under root 3 over 5 under root. Fine. And now y is equals to 2 by 3x and z is equals to 0. So when x is positive, y is going to be positive. When x is negative, y is going to be negative. So our y will become 2 by 3 multiplied by 3 under root 3 over 5 under root. So it is 2 under root 3 over 5. Now it is plus minus with respect to x. So for x is equal, for our points will be 3 under root 3 over 5 under root. For that our y plus, so x is plus, so y is plus. So it is 2 under root 3 over 5 under root and 0, 1 point. Second point is minus 3 under root 3 over 5 under root. Minus 2 under root 3 over 5 under root. Okay, my battery is getting low. So, no, not my, I mean, tab battery is going low. So hopefully, this rest is gone. Oh no. So you got the point. You will just, the points are there. Okay. We have found the points. Now I don't have the battery in my tab, but I will send you the solutions. Okay. Hello.
Does that mean it's over?
So I don't want to be over, but the thing is my tab is not getting charged and I hardly charged it and it is now going down. Okay, any other question you want to do?
Will you send the solutions to all the questions after? Or
Yes.
at least the ones you
Do
do
you
get
want
through?
me to send all the questions answers?
That would be nice. Yes.
Yeah.
Okay, I will.
Yes, yes.
Okay, I will send all the questions answers. So hopefully it will be helpful.
Okay, thank you so much. That's very helpful.
Okay, most welcome.
Thank you very much. Have a good night.
So you anybody said to me use Green's theorem, another theorem. So try them. Okay.
Just a quick question. Do you know if there's gonna be Laplace on the exam? Because I know the professor said he's giving us a Laplace table, but I didn't like all the other previous exams I've looked at. None of them have like a direct Laplace question.
Yeah. So I don't know about the exam
Oh, okay. Thank you.
because you know they think that TAs have friendship with the students, so they keep it away from us. So I have no idea. Any other question? I will try to post it. I will send to MUES and they will post it. I will try and keep an eye for the typos because when I'm doing, I also make mistakes.
Sorry, Fadia, you say you're giving us all these solutions?
Say it again.
Sorry, did you say you're giving us all the solutions to the final exam that's posted?
Yes, what I have tried, I will send you, but you are in the class. You might have better idea how to solve the questions, but I solve them. I will give you my solutions.
Okay, right. Thank you.
I will send it on MUES because there are 100+ people, so it is not possible to send everyone by email. So they will post it hopefully tonight or tomorrow. We are learning now Laplace. Laplace is a way to solve the equation, differential equation. So it will be on MUES website. You can solve volume or area using Laplace. So I never use that. So I don't know. Try it. So integration, we do volume by integration, but differential equation is different. Try it, whatever your idea is. Yes, because my tab is out of charging again and it gave me hard time. So hopefully I will send the solution soon. You too. Welcome. Welcome. I will send them soon to MUES and they will post it on their website. We have discussed, you know, we have discussed 5 or I think 5 questions or 6 questions, so you will be fine. Yes, you too. Welcome. So now I'm closing it. Okay, bye everyone.